Use the elimination method to solve the system of equation 3x squared minus y squared equals 11, x squared plus 4y squared equals 8. To use elimination methods, we need to multiply one equation by a non-zero real number, and then add it to another equation, hoping to cancel out one variable, hoping to eliminate one variable. It doesn't matter which variable we eliminate first. In this case, since the terms with y squared already have opposite signs, and observe that if we multiply the first equation by 4, which we're allowed to do, we have 3x squared times 4 is now 12x squared. Negative y squared times 4 is now negative 4y squared. And 11 times 4 is 44. Make sure we take every single term in the equation, both the left and the right hand side, and multiply by that non-zero number. In this case, don't forget to take 11 times 4 on the right hand side. It is very important. And if we do that, observe that we have the same amount, but the opposites of the y squared term. We then rewrite the second equation, x squared plus 4y squared equals 8. We then add the two equations, and this is what we're allowed to do. We obtain 13x squared, and now the y squared terms canceled out. 44 plus 8 is 52. X squared equals 52 over 13. X squared equals 4. 4 times 13 is 52. X equals plus or minus the square root of 4, so x equals plus or minus 2. We then perform a back substitution. It does not matter which equation we use. For x equals 2, we will use the second equation, x squared, which is now 2 squared, plus 4y squared equals 8. 4 plus 4y squared equals 8. 4y squared equals 8 minus 4, which is 4. Y squared equals 1. And so y equals plus or minus 1. And so with x equals 2, we end up with either y equals 1 or y equals negative 1. We only checked x equals 2. In fact, we haven't checked it yet. We only plug in x equals 2. We still have x equals negative 2. When x equals negative 2, the second equation is negative 2 squared plus 4y squared equals 8. And this will be y squared equals 1 because negative 2, the quantity squared, will give us the same equation as above. And so we see that y equals plus or minus 1. What this means is that when x equals negative 2, we either have y equals 1 or y equals negative 1. And so in this case, there are 4 solutions. We're not done yet. We still need to check to see if any of these is an extraneous solution. To check the solution, we just simply plugged in one by one. For x equals 2, y equals 1, the first equation is 3, 2 squared minus 1 squared, and we want to see whether this is 11 or not. This is 3 times 4 minus 1. 12 minus 1 is 11, so yes, this checked out. The second equation is x squared, so this is 2 squared because x is 2, plus 4 y squared, y is 1, and this is 4 plus 4, so this is 8, this checked out. So yes, x equals 2, y equals 1 is one solution. Next, we checked 2 comma negative 1. The first equation is 3 times 2 squared minus y is now negative 1, and we square this. This is 12 minus negative 1 squared is 1, so this is 11. This checks out. The second equation is x2 squared plus 4 times y squared, but y is -1. This is 4. -1, the quantity squared, is +1. 1 times 4 is 4. So this is 8, so this checks out as well. X equals 2, y equals -1 is also the solution. Next, for x equals -2, y equals 1. The first equation is 3 times -2 squared minus y squared. And we see that -2, the quantity squared is 4. 3 times 4 is 12. 12 minus 1 is 11. This checks out. The second equation is x squared, so that is a -2, the quantity squared, plus 4 times y squared. This is 4 plus 4, which is 8. This checks out. So yes, x equals -2, y equals 1 is the solution. And lastly, x equals -2, y equals -1. The first equation is 3 times x squared minus y squared. This is 3 times 4, which is 12, minus 1, which is 11. This checks out. And the second equation is x squared, -2 squared, plus 4 times y squared. Y is -1. This is 4 plus 4. So this is also 8. This checks out as well. So yes, x equals -2, y equals -1 is also the solution. We didn't really have to check these because we see that all of these are the squared. So if the positive works, then the negative also works. So we have 4 solutions in this case.